Our on-site technical teams work very closely with our customers from concept right through to final processing. This includes process development, cycle design, cycle optimization, protocol generation, execution of cycles, all the associated laboratory testing to deliver a robust, sustainable process for routine processing that meets all the current regulatory requirements. There are a number of reasons why people would choose ethylene oxide. One reason would be cost. Ethylene oxide is a very cost-effective sterilisation method in that you're sterilising products in large volume. A second reason why people would choose it is for processing flexibility. A well-defined, well-validated process will allow a customer to sterilise a wide range of products in a single cycle. And that allows them a lot of flexibility to mix and match their product portfolio at short notice to meet customer requirements. A third reason is the impact on the product itself. As a low temperature sterilisation method, typically between 40 to 50 degrees, the process does not have a negative impact on the form and function of the medical devices themselves, making it very suitable for a wide range of medical devices.
The sterilisation process is carried out using either 100% ethylene oxide or with a pre-mixed blend of ethylene oxide and an inert gas such as carbon dioxide. Whether using 100% ethylene oxide or a predefined blend, the process is fundamentally the same. The main difference is that with 100% ethylene oxide, the sterilisation process typically takes place under vacuum, while with the blended gas, it takes place under positive pressure, typically less than 2 bar. Traditional ethylene oxide processes typically involve 3 stages. The first of these stages is preconditioning, which involves raising the temperature and humidity of the load to facilitate the sterilisation process. After a predefined preconditioning time in a humidified heated area, the load is transferred into the sterilisation chamber. There are a number of distinct steps. The first step is to pull a vacuum to remove air from the chamber, followed by a leak rate test to ensure that there are no leaks. For 100% processes, nitrogen is injected and evacuated to reduce the air in the chamber. A conditioning phase takes place to ensure that the load humidity is at optimum levels to optimize the lethality of the ethylene oxide. Following a conditioning dwell period, ethylene oxide is added to the chamber to a predefined pressure to give the desired concentration. Ethylene oxide is allowed to soak into the load over a specified dwell period that has been validated to deliver the required sterility assurance level. Once the minimum gas dwell period has elapsed, the ethylene oxide is removed from the chamber through a series of vacuums and washes. For 100% processes, nitrogen is used instead of air until the ethylene oxide concentration is at a level where it is safe to add air. Steam may also be incorporated into these washes to further enhance the removal of ethylene oxide from the load. All emissions from the chamber are diverted to emission control equipment to ensure that emissions to atmosphere meet the required national limits. Once the sterilisation process has been completed, the chamber is brought back to atmospheric pressure and the load is removed. Where required, product may require additional aeration to bring product residual levels down to specified limits. This final stage is typically carried out in heated areas with high volume air changes to facilitate the removal of ethylene oxide residuals from the product. The period of aeration will be a function of the materials used in the products and their propensity to hold on to residuals. As trusted partners for a vast range of sterilisation solutions to a wide variety of industries, including medical devices, pharmaceuticals, specialist applications and contamination control sectors,